So my name is Astori. I'm a software developer. I'm actually at the moment going back to academia and moving countries. But previously I worked at Decathlon and Amazon for the Alexa AI org. And today I'm going to be talking about optimizing Python code and providing some tips and tricks for faster code. So this talk is based actually on a Medium post that I published some time ago, and I'll provide the link for it at the end. But here I'll just dive right into faster Python code. So what is fast code and how do we define it? And more importantly, how can we measure it? So there are three aspects against which we can measure the code. It's time, CPU consumption, and memory consumption. And for each one of those, there's a great deal of tools available in Python. So for instance, for time, you can use time or timeit modules. Quick caveat here, measuring time is actually a little tricky. For instance, your operating system can interfere while you're doing it, so you have to be a little bit aware about things happening, how to take care of that, sort of in order to avoid getting skewed results. And there's a great read that I'm linking here that's called Falsehoods Programmers Believe About Time. You can also just simply Google the title and find it. It's been republished in multiple platforms on the web. But for the couple of examples that I'm going to use later in the presentation, I'll measure time. Actually, it's still accepted as one of the general benchmarks. For CPU measurements, there is a very popular C profile module, and for memory, memory profiler. As a matter of fact, I also have a Medium post about profiling Python, and I'm attaching a link here below on the page, so feel free to check it out. There have a little bit more of details about those packages, how to use them, what output they provide, a little bit more of details, for example, the difference between the time and timeit modules, so feel free to check it out. So what are the things that you can do when you start your project, you're working with lots and lots of data, and all of a sudden you realize your code is hitting a wall and it's just taking forever to run? What can you do? There are a number of things that you can do, luckily, starting from very straightforward kind of tweaks in your code that you can apply, all the way to more generalized and sophisticated approaches that I'll talk a little bit more about later. So I'll start with the simpler things. The first suggestion that comes to mind is look out for places where you can replace for loops with list comprehensions. So what I mean by this and what value do they bring? Let's take an example. So here I have a dummy function, square integers with for loop. All it does is it creates the output list and then iterates over each integer within the limit, appends its square to the output list, and finally returns the list. So when I run this function, and here you can see a sample code, how to call the timeit function within your Python code and then print its output to standard output. So in my machine, the output was about 9.3 seconds. Can we do better? Yes, we can with list comprehension. So here at the top screenshot is a new function which achieves exactly the same thing using list comprehension. In the middle screenshot, you can see my code calling timeit again and printing out the evaluation. And this time it's slightly over 6 seconds, which, if you think in relative terms, it's a great improvement. And of course, if I were working with real life, real large data input, the benefit would be even more perceivable. But that shows the point of the benefit of list comprehensions in Python. That's a great tool. Can we do maybe even better? Actually, yes. It might be a good idea to try and avoid unnecessary for loops and even list comprehensions altogether. So one of the patterns that I come across in real life applications sometimes, but actually a lot more often in this kind of lead code coding interview problems, where you know that you're going to be iterating over, say, a list of items and do some computation for each one of them, and you want to store this computation in a predefined list or array. The nice trick that you can use in Python is use the multiplication shortcut. So here in my example, say I have a rows list, which is a list of textual items, elements, and I can simply multiply the default 0 value by the length of this input rows list, and then my computation per row list would look something like the output below. So that actually avoids the loops and doing list comprehension altogether. There are some caveats to this approach as well. I'm not going to go into a lot of details here because of the scope of the lightning talk, but I'll be happy to talk a little bit more about it. I love this topic. If anyone has any further questions. What else can we do? Another area that I would suggest to explore and look into is the Python built-ins. Especially if you're maybe starting out in coding, data science, sometimes it even feels a little bit tempting to write this kind of logic by yourself, because you can definitely do it. But I would recommend against. So the Python built-in functions that I'm talking about include things like very simple things like sum, max, also map, reduce, filter, etc. And the great thing about them is that they're oftentimes implemented in C under the hood. They're optimized for various scenarios, and so they'll do the things a lot more efficiently than the code that I might have written myself, for instance. Another example that I would like to mention here is something that also shows up a lot in real life applications if you're working with the textual data like I had to do. And also in this kind of lead code problems where you maybe need to reduce an input string or something like find all the non-repetitive characters or something like that. So you might also be tempted to just start building the output string character by character, but it might not be a very efficient way to do it. It might be a lot more efficient to actually append the characters to an intermediate list, and then call the strings module, the string module's join method on it. Why? Because when you're building a string character by character under the hood, the Python is going to store every intermediate version of the string and thus take up a lot of memory. And imagine if you're working with really large data input, they'll take up a lot of memory and will really slow down your program. And the last one I wanted to talk about here and give an example for is the operator item getter. Is very helpful, very handy in the following kind of examples. So say I have a list of tuples of first name, last name of users, and I want to sort them, but I would like to sort them by last name rather than the first name. That would be, which would be the default. So in that case, I can use the operator item getter, highlighted here in magenta, as a key, and you can see the sample output that it would provide in that case. And it would do it very quickly, very nicely. What else can we do? Another thing to think about in your code is if you're working with a lot of objects and their attributes, and if you're referencing those attributes in one piece of code quite a few times, it might be a good idea to assign them to local variables. So a very typical example here, imagine I have a rectangle object and has its height and width attributes. So here I'm going to assign them to the rectangle underscore height and rectangle underscore width variables, and then reuse them later in my code to compute the surface, and then maybe a little down below the perimeter, or maybe something else. So why it could be a little bit more efficient? It's probably not going to shave off a lot of execution time, but to put it super concisely, the thing is that if you're referencing the object's attributes directly, your Python has to retrieve the self object first and then its attributes. Whereas if you're using local variables, it skips one step, so it can come in handy. Along the lines of thinking carefully about your objects and data structures, and generally, my general suggestion is always to explore and learn, know the data structures and the objects that you're using. It's new objects for you well, and choose the approach wisely. So what are the kinds of things I mean here? For example, if you're working with Python dictionaries and you want to check a key in a dictionary, which is actually a very interesting question. There are like a lot of sides to it, but from the very beginning, at least Python 3 allows you two versions of syntax. You can use the top one, if key and dict, versus the bottom one, if key and dict dot keys. And you can use either, as I said, but it turns out in Python 3, the top one is going to be a little faster. So why not use that? Again, it as usual, it all depends on the general logic of your code. But if you're not using the actual keys for anything else later in your code, just go for the faster, simpler version. Another dilemma that I see pop up sometimes, and that actually trip up even experienced developers sometimes, is this choice of list and set data structures. When you know that you're going to retrieve an element from the container, the data structure, which one to go for. Because we know that retrieving an element from a set is one, super efficient. Let's make great use of that. On the other hand, watch out. If you're actually getting a list as an input, which is very frequent in Python, you might be tempted again to turn this list into a set first and then retrieve an element from there. However, if you're only retrieving one element, what will happen? You have to iterate over each element of the list first to be added, for those elements to be added to the set. So you'll actually create this extra overhead that you don't need, and thus you won't really get any benefit from retrieving an element from a set. So once again, know your data structures and your objects well, and choose an approach wisely. But what happens if you've replaced your loops with list comprehensions everywhere you could, and local variables don't help anymore? What can you do? So that might be a time to pull out the big guns. So it might sound like you're working with a very big application with real life data at this point. And if you're not familiar yet with some of those fascinating libraries that are there for Python, like NumPy and Pandas, they definitely should be on your radar. So NumPy uses their own implementation of arrays, NumPy arrays, that are more compact and faster than Python lists. I'm not going to go into detail how they're implemented. That's actually open information. You can find it on the web. It's really interesting. But here I'm just adding some information about the benefits and the efficiency of NumPy, taken from the NumPy official documentation. And similarly, Pandas is super popular. It uses some of the mechanisms like vectorization that also allows you to avoid loops altogether and make things run a lot faster. However, pandas are super interesting because some of its default data structures are actually not even designed to be super efficient, but it's such a mature library by now that there are so many ways to even scale it to large data sets and fine-tune its efficiency, that it's even provided on its official documentation, and I'm providing a link here, so definitely check that out. And lastly, one more thing that I wanted to mention here is, especially if you have a long-running, really large application, what might really be beneficial is just-in-time or JIT compilers. So JIT compilers collect information about data types that your code is using, and thanks to this information creates very specific machine code that helps your program run a lot faster. So on the other hand, something to keep in mind that you won't probably, not probably even, you won't see really benefit from JIT compilers if you're applying it to like one-off short scripts. But if it's a big program, there could be your friend. And there are two really popular ones. One with the PyPy, which is the Python implementation of Python. And here again, I'm providing some basic information about its benefits and some numbers, benchmarking numbers that is mentioned in their official documentation. And the other one is Numba, which is a JIT compiler on its own, that also claims to be at least a few times faster than the CPython standard implementation. So yeah, that's all I have for my suggestions for today. Here at the bottom of this page, I'm linking again the URL for my original post on Medium about optimizing your Python code. Feel free to check it out. Also, feel free to follow me on Twitter or connect on LinkedIn. Thank you so much for your time.